On the morning of June 30th, 1908, something extraordinary happened. The sky over the remote Siberian wilderness was calm, with the sun just beginning to rise, casting a serene glow over the landscape. But this tranquility was about to be shattered in the most dramatic way imaginable. A gigantic explosion rocked a remote part of Siberia, Russia. The blast was so immense that it was heard hundreds of miles away, and the shockwave it generated was felt across continents. The blast was so powerful that it flattened trees over an area twice the size of London. Imagine a forest, dense and teeming with life, suddenly laid bare, with trees toppled like matchsticks, stretching out as far as the eye could see. The event, now known as the Tunguska Event, remains one of the most intriguing mysteries of the 20th century. Despite numerous expeditions and countless hours of research, the exact cause of the explosion is still debated. The Tunguska Event was unlike anything witnessed before. It was not just the scale of the destruction that was baffling, but also the absence of a clear impact crater, which left scientists scratching their heads. It generated shock waves that traveled around the globe, causing atmospheric disturbances that were recorded as far away as England. The energy released was estimated to be equivalent to 15 megatons of TNT, making it one of the most powerful explosions in recorded history, and its effects were felt thousands of miles away. People reported seeing strange lights in the sky and feeling the ground shake, even in places far removed from the epicenter of the blast. The cause of this massive explosion has puzzled scientists and fueled speculation for over a century. Some theories suggest a comet or asteroid explosion in the atmosphere, while others propose more exotic explanations like a mini black hole or alien intervention. The Tunguska event continues to captivate the imagination of researchers and enthusiasts alike as they strive to uncover the truth behind this enigmatic occurrence. The Tunguska event occurred in a remote region of Siberia known as Krasnoyarsk Krai. This area, covered in dense forests and sparsely populated, is known as the taiga. The exact location of the blast was near the Podkamennaya Tunguska River, hence the name Tunguska Event. The remoteness of the region played a significant role in the limited understanding of the event. It was difficult to reach, and initial investigations were delayed for years due to the challenging terrain and political turmoil in Russia at the time. While scientific data about the event was scarce, there were numerous eyewitness accounts from the indigenous Evenki people living in the region. These accounts have been passed down through generations, becoming an integral part of their oral history. The Evenki, known for their deep connection to the land and their keen observational skills, were among the first to witness the extraordinary phenomenon that unfolded in the skies above their homeland. They described a fiery ball of light streaking across the sky, followed by a deafening boom that shook the ground and knocked people off their feet. The brightness of the meteor was so intense that it lit up the night as if it were day, casting eerie shadows and causing animals to panic. The explosion was heard hundreds of miles away, creating a sense of awe and fear among those who experienced it. Some recounted feeling intense heat, even at a distance from the epicenter. The heat was so severe that it caused trees to ignite and the ground to smolder. People miles away felt the scorching wave, and many suffered burns despite being far from the direct impact. The air was filled with the smell of burning wood and scorched earth, adding to the surreal and terrifying nature of the event. Reindeer herds were scattered, and tents were destroyed by the shockwave. The force of the blast was so powerful that it flattened entire forests, leaving a barren landscape in its wake. The Evenki, who relied on reindeer for their livelihood, faced significant challenges as they tried to regroup and rebuild their lives in the aftermath of the disaster. The loss of their animals and homes was a devastating blow to their community. These first-hand accounts, though lacking scientific measurements, provided valuable insights into the scale and power of the event. The stories told around campfires and in communal gatherings helped preserve the memory of the event, ensuring that future generations would understand the magnitude of what had occurred. The Evenki's detailed descriptions have been invaluable to researchers trying to piece together the events of that fateful day, offering a unique perspective that blends cultural heritage with natural history. The first scientific expedition to the Tunguska site didn't occur until 1927, almost 2 decades after the event. Led by Leonid Kulik, a Russian mineralogist, the team faced a challenging trek through the dense Siberian wilderness. Upon reaching the area, they were astonished by the scale of the destruction. Millions of trees were flattened radially outward from the epicenter, forming a butterfly-shaped pattern. Strangely, there was no impact crater, which deepened the mystery surrounding the event. Section 5. The asteroid theory. The most widely accepted theory among scientists is that the Tunguska event was caused by an asteroid or a comet exploding in the Earth's atmosphere. This airburst would explain the lack of an impact crater and the pattern of the fallen trees. The intense heat generated by the object entering the atmosphere would have caused a massive explosion, releasing energy equivalent to thousands of Hiroshima atomic bombs. The shockwave from this explosion would have been responsible for the widespread devastation. Section 6. Other explanations. While the asteroid theory is the most plausible, other hypotheses have been proposed over the years. Some suggest a natural gas explosion from beneath the Earth's surface, while others entertain the possibility of a small black hole colliding with our planet. However, none of these alternative theories can fully explain all the observed phenomena associated with the Tunguska event. The lack of any significant radiation or geological anomalies makes these alternative explanations less likely. Section 7. The Tunguska Event's legacy. The Tunguska event, despite its destructive power, had a lasting impact on scientific research. It highlighted the potential threat posed by asteroids and comets to our planet. The event served as a wake-up call, prompting scientists to study near-Earth objects, or NEOs, more seriously. Today, various programs are dedicated to detecting and tracking potentially hazardous NEOs. The goal is to identify threats early on and develop strategies to deflect or mitigate the impact of any future Tunguska-like events. Section 8. A mystery for the ages. More than a century after the event, the Tunguska event continues to fascinate and intrigue. On the morning of June 30th, 1908, a massive explosion occurred near the Podkamennaya Tunguska River in Siberia, flattening an estimated 80 million trees over an area of 2,150 square kilometers. The explosion is generally attributed to the airburst of a small asteroid or comet, but no definitive evidence has ever been found. The lack of a definitive answer, despite numerous investigations, adds to its allure. Scientists have proposed various theories, ranging from a comet or asteroid impact to more exotic explanations like a mini black hole or alien spacecraft. Each expedition to the site uncovers new clues, but also raises more questions, deepening the mystery. The event serves as a reminder of the vastness of our universe and the mysteries it holds. The sheer scale of the explosion, which released energy equivalent to 10-15 megatons of TNT, is a humbling testament to the forces at play in the cosmos. It challenges our understanding and compels us to look beyond our planet for answers. The Tunguska event is a stark reminder that our planet exists within a cosmic shooting gallery. Earth is constantly bombarded by space debris, most of which burns up in the atmosphere. However, events like Tunguska show that larger objects can and do make it through with potentially devastating consequences. While the chances of experiencing another such event in our lifetime are slim, the possibility remains, making continued research and vigilance essential. Modern technology allows us to monitor near-Earth objects more effectively, but the Tunguska event serves as a sobering reminder of the importance of preparedness. As we continue to explore the universe, the lessons of Tunguska will guide our efforts to protect our planet from similar cosmic threats. Section 9. Our Cosmic Neighborhood. The Tunguska event, while a singular event in human history, is not unique in the grand scheme of the cosmos. Our solar system is populated by countless asteroids and comets of varying sizes. Most of these objects pose no threat to Earth, but some have orbits that intersect with our planet's path. Understanding these celestial objects, their trajectories, and the potential risks they pose is crucial for safeguarding our planet's future.